Okay, what I'm going to have you do for this video, Saybrie, is watch this and then try these problems out. The best thing I think you could do, again, is to do the work first. Try the work on the study guide first, and then after you've tried it, then watch the video as a guide, and then we could really focus on the ones you need extra help on. So here we go. First one is a FOIL problem. So I'm going to take the first, the outside, the inner, and the last, and times that. And again, notice this is one of those special cases. So x times x gives me x squared. That is the first. X all the way down here times negative 1 is negative 1x. Positive 1 times x gives me plus 1x. 1 all the way down times negative 1 gives me negative 1. And what happens with these special cases, the two middle terms will cancel away, and I'm left with just x squared minus 1. So if you were to FOIL backwards, remember this is a special case. You got a minus, you got a number that could be square rooted. That's one of those special cases, 1x plus x minus. Next one, 4x times 5x gives me 20x squared. 4x times negative 7 is negative 28xy. 5y times x, I'm going to write that 25xy again. I'm going to write it in that order, 25xy. And then 5 times negative 7 is negative 35y squared. So for here, I'm going to combine these two middle terms. Negative 28 and positive 25 give me negative 3xy. So I have 20x squared still minus 3xy. And I bring down the minus 35y squared, and that is after the FOIL. So hopefully that helps with those first two. Alright, number 3. 3 has you take out the greatest common factor. So if you remember, for this, it's going to be the x, and then the smallest power, that's what you're looking for. So x squared is the biggest thing. There's no plain number to take out, so it's just going to be x squared. And if you remember, you take that x squared and put it out front, and then you find the two things on the inside. So if you were to distribute, you'd end up back at x to the 7th minus 20 or 12x squared. So what has to be on the inside here? It has to be x to the 5th. Because x squared times x to the 5th is x to the 7th. And then right here is just plain old minus 12, because x squared times negative 12 is negative 12x squared. So here I'm showing you what happens when you distribute. X squared times x to the 5th, x to the 7th. X squared times negative 12 is negative 12x squared. Greatest common factor. For here, I need the greatest common factor of the numbers, and then the lowest power for each of these x's. For these numbers, the biggest number that goes into both is 4. And then for the x and the y, the smallest power on the x is x. The smallest power on the y is y. So my greatest common factor, biggest number 4. And then the smallest of the two powers, that's the least that they share. So 4xy. And then again, distributing, figuring out what times this gives me back to 28x to the 5th y. So I would have to be 7x to the 4th plus 9y squared, because 4x times 7, or 4 times 7 gives you the 28. Then x times x to the 4th is x to the 5th. You already have y, so that will give you 28x to the 5th y. Down here, 4 times 9 is 36. X is already there, but y times y to the 2nd would give you y to the 3rd. So that is the greatest common factor, 4xy times 7x to the 4th plus 9y squared. And here I'm showing you what happens again if you distribute 28x to the 5th y, 36x y to the 3rd. So hopefully that helps. Alright, problem 5. For these, I am just factoring using the x method. I believe one of these is prime. So if I have x squared plus x, that's positive 1 on top and negative 72 on the bottom. Here I write the two factors that work, which is 9 and negative 8. But the other ones, I list out all the factors. So remember, when you're factoring, you need to list out all the pairs, because it's always that pair you forget to write that works. But here, I just cheated a little bit and just wrote the two that work. So that is 9 and that is negative 8, because 9 times negative 8 is negative 72. 9 minus 8 is 1. And just remember, put those numbers in there, x plus that 9, and then the x minus that 8. And also remember, this is just factored. It's not solved. And of course, you could flip that around to write x minus 8 first, and then x plus 9 second. Alright, for some reason I skip over here to problem 7 first, and then I do 6 after, but that's okay. So for problem number 7, when I draw my x with 47 on top and 48 on the bottom. So 48 does have a lot of factors. 48 times 1, 2 times 24, 6 times 8, 12 times 4. I think on this one I'm listing all of them out. I might have missed one. But for this one, there is no factor that works. None of these work. There's no pair of numbers that times give you positive 48 and positive 47. If this would have been negative 48, you could have got that to work, maybe. But this is prime polynomial. No pairs multiply to give you 47. I'm sorry, multiply to give you 48, and add or subtract to give you 47. This is prime. So know that. If no pairs work, pretty much it's going to be prime. All right, number 6. 6, I draw my x with negative 2 on top and negative 48 on the bottom. List the factors of negative 48, so 48 times 1. And here I think I list them all. I think I grabbed my calculator during that little pause. So 48 times 1, I'm sorry, not 48, 24 times 2. So I'll switch that. 24 times 2. It is also 3 times 16. 4 times 12. 6 times 8. And again, make sure you list them all. And the two that works are going to be 6 and 8. With 6, I believe positive, and 8 is negative, because 6 times negative 8 is negative 48. 6 minus 8 is negative 2. So inside there I put these numbers, x plus 6 and x minus 8. Alright, for number 8, what he suggests doing, and I agree, is try to find the biggest common factor out of all these and take that out. That will make what you're factoring easier. So of all these, they all share a 3. So I put a 3 out front and reverse distribute and find out what's on the inside. It would be just x squared minus x minus 6. Because if you took 3 times x squared, 3x squared, 3 times negative x is negative 3x, 3 times negative 6, negative 18. So that makes what you're factoring easier for you. And just remember to leave that 3 in your final answer. So if I make my x method there with negative x, or negative 1 and negative 6, the pair that works, I believe, is 3 and 2, with 3, I believe, negative and the 2 positive, because negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. And then put those in there, x minus 3, x plus 2. But remember to put that 3 out front. You will get this wrong if you forget to put that 3 out front. So a little easier way. And of course, you could always write those in a different order, x plus 2 and x minus 3. You could write that in a different order, of course. But again, take that number out first if you can, but make sure you write it in the answer. Alright, for this is grouping, factoring by grouping. So I'm going to look at this first pair and the second pair and take out the greatest common factor in both and put those back together. So the greatest common factor for those first two is going to be 5x. 5 is the biggest number that goes into both. X is the smallest of the power that they share, so 5x. And what has to be on the inside, it would have to be 2x minus 3, because 5x times 2x is 10x squared. 5x times negative 5 is negative 15x. Next, put the minus there. And for these two, the biggest number that comes out is 2. There's no x there because they don't both share an x. And then inside there it has to be 2x minus 3. Because again, negative 2 times 2x would give you negative 4x. Negative 2 times negative 3 would give you positive 6. And what happens is, when these are the same, you write that as one of the pairs. And again, I'm showing you why it would have to be negative 2 there and negative 3 on the inside. So you share, these are the same. So you write that in one of the pairs, just one of them. And then you bring the other two parts together into the other pair. So that 5x minus 2. And I guarantee you, if you were to distribute this, it would FOIL back to this original problem right here. Alright, 10 is a more difficult one where there's no number you could take out. So you put that negative 5 on top, and then make sure you times 7 times negative 2, which is negative 14. Remember, you times those numbers. And then these are the ones with little fractions on the side. So the two numbers are going to be 7 and 2, with 7 negative and 2 positive. And then remember, on these, you put that little number on top, little fraction. You put the first number on top. A number goes on top. So 7 over negative 7, 7 over 2. You need to reduce. So these both get divided by 7, which gives me 1 over negative 1. So that pair is going to give me one answer. And the other one is fully reduced, so leave that alone. So 1 comes from the top number, the 1x, or just plain old x, minus 1. And the second one is 7x plus 2. And of course, you could write that in any order. You could write that 7x plus 2 times x minus 1. That order doesn't matter. And then that 1 in front of the x doesn't matter. And of course, you could flip these around too. You could write that as 7x plus 2 times x minus 1. And I showed you that there. Alright, number 11. So this one, they want you to take out the greatest common factor number first, which reduces the numbers down. Otherwise, you're timesing big, huge numbers. So 5 goes into all three numbers. So what has to be on the inside is 3x squared to get 15x squared. 5 times 13x will give you negative 65x, and then negative 10 will give you negative 50. And again, what happens is that makes it much easier for you to factor what's on the inside. So that's going to be negative 13, and then I'm going to erase this shortly because I forgot to times. So 3 times negative 10, if I erase that here shortly, that really is negative 30 down there, so don't forget to times like I did there. So negative 30. And then the two pairs that work, if I list them all out, 3 and 10, that looks close, but that one not sure if it's going to work. 6 and 5, 30 times 1, and then 15 and 2, that's the one that's going to work. So that's going to be negative 15 and positive 2. And then for this one with the harder number with number in front, you put that as a fraction with that number on top. So 3 on top and 3 on top of the 2. Reduce this down. That one's good to go. Dividing both top and bottom by 3 gives me 1 over negative 5. And then those give me the two parts of the factored answer. So it's going to be 5 on the outside. Don't forget that 5 on the outside. And then for some reason I put 3 here, so don't put a 3 there. Make sure there's a 5 there. I'm not sure why I put a 3. And then x minus 5, 3x plus 2. So again, please be careful. Don't put the 5 right there. For some reason, I have no idea why I put 3 there, but that should be a 5. All right, special case. This is a square rootable number and a minus there. So again, that's going to be the one where you have x plus a number, x minus a number. So x plus the square root of 49, x minus the square root of 49. So that's x plus 7 and then x minus 7. Special case. Just like x squared minus 1 is a special case. And again, if you were to FOIL this, that middle term will go away. Minus 7x plus 7x will cancel away. Minus 49. So that middle term cancels away on those special case ones. All right, number 13. They want you to solve these. This one is factored already. So I'm going to take those pieces and set them equal to 0. Again, this is just factored. It's not solved, it's factored. So to solve it that one step further, you take each of those and you set those both equal to their own little 0. So 4x plus 1 equal to 0, 5x minus 3 equals 0. And then to solve those both, two-step equations, minus 1 on both sides, bring down the 4x and the negative 1, and then you divide both sides here by 4. And that gives you x equals negative 1/4. Over here, if I add 3 to both sides and then divide by 5, I get 3/5. So add 3 and I get 5x equals 3. Divide by 5 and that gives me x equals 3/5. Those are my two answers. All right, this one I need to factor first and then solve my factored pieces. So x squared plus 5x minus 84. I draw my x method. I draw my x. Factor it and then solve those pieces. So with 5 on the top and negative 84 on the bottom, the only two numbers that times give you negative 84 and add to give you positive 5 are going to be 84 and 1. I think the other pair is 12 and 7, and that's going to be the pair that works, I believe. 21 and 4. 42 and 2. Again, just getting the practice of writing all the pairs. So 12 and 7 with 12 positive, 7 negative. And remember, these are not your answers. These are just the factored answers. So x plus 12 and x minus 7. Don't be mistaken and put these as the answers. Because when you set these equal to 0, you see that the answers are actually the opposite of these numbers. So x plus 12 equal to 0, and then x minus 7 equal to 0 gives me x equal negative 12. So x plus 12 equals 0, minus 12 on both sides. X minus 7 equals 0. Add 7 there, so minus 12 on both sides gives me one answer, which is x equals negative 12, which is always the opposite when you just have x in there. And then the other one is x plus 7 when I do the opposite of that work in there. So x equals negative 12, x equals 7. Alright, so that is solved. Those answers would work if I were to plug in 7 here and 7 here. That would times and subtract 84 to get 0. Alright, 15. To solve this, you need to subtract 18 first. You need all the numbers on this side to factor. So that would be x squared plus 7x minus 18 equals 0. So do that first. And then if I draw my x to factor it and then solve it with positive 7 and negative 18, 18 is 9 and 2, 6 and 3, 18 and 1. I believe 6 and 3 don't work, but 9 and 2 do. So that would be positive 9 and negative 2. But again, remember, these are not your answers, just the factored answers. X plus 9 and x minus 2. But again, the answers are the opposite of these numbers. So x plus 9 equals 0 will give you negative 9. X minus 2 equals 0 will give you positive 2. So minus 9 gives you x equals negative 9. And x plus 2 gives you x equals 2. So those are the two answers. Alright, for this one, this is one where you need to break it up into two numbers where one of them is square rootable. This is a pretty difficult number here. So I'm going to list all the perfect numbers you need to know. So 4, 9, 16, 25, 36, and I'll go one more. I think I go to 49. So all these have perfect roots. Square root of 4 is 2, square root of 9 is 3. So this is 4, this is 5. Square root of 36 is 6, square root of 49 is 7. I think in the number 294 is, I'm not quite sure using my calculator, ends up being, what's that, 49? So if I divide 294 by 49, I get 49 times 6. And then that splits up into 2, 49 times root 6. And then you square root the 49 to get your plain old 7 and root 6. Notice when I square root that, the square root symbol is gone. Don't write it again. So when you square root a number, don't write that double root. Don't do that. When you square root 49, you get the plain number 7. And I think I did in the side here, I did a little easier one there. I did 40, which is a little bit easier, which is 4 times 10. And then you split that up into root 4 times root 10. And then you square root the 4 to get 2. And then bring down the root 10. And notice that square root symbol is gone. Alright, for this one, I'm going to square root both the top number and the bottom number. So I'm going to split it up into a little fraction. So that gives me the square root of 100 over the square root of 49. And then you square root each separate. So split it up into two separate square roots. Square root of 100 is 10. Square root of 49 is 7, so it ends up being the whole number 10 over 7. Alright, this cubic root is a little bit more difficult. So there's no number times itself 3 times, it gives you 18, but there is a number in 16 that has a cubic root. The answer on the key has x's in it. I'm not sure why the key has x's in the answer because the problem itself has no x's, so I'm not sure about that. You might want to talk to him on Monday maybe. But that is the square root of cubic root of 16 is what number times itself 3 times. So you're going to have to do a little trick on that one. You're going to have to break that up into 8 times 2. Because 8 times 2 gives you 16. And 8 has a cubic root. There is a number times itself 3 times that gives you 8. So you break that up into 2 times 2 times 2 to the third, and that is 8 right there. I know that's kind of tricky, but 2 to the third is 8. 2 times 2 times 2 is 8. So again, break that up into 2 times 2 to the third, or 8 times 2. And what happens is the cubic root of 8, or 2 to the third, is just plain old 2. So again, if I wrote that as an 8 right there even, that'd probably be better if I would have wrote that as an 8. 8 times 2 is 16, and the cubic root of 8 is 2, because 2 times 2 times 2 is 8. And here I wrote it a little bit more difficult, 2 to the third, but that's okay. So when you split that up into 2 to the third cubic rooted times the cubic root of 2, that ends up being the whole number 2 times 2 cubic root 2. And again, might have been a little bit easier if I wrote this as an 8 right here, and then just did the cubic root of 8, which is the whole number 2. Probably talk about that when we meet again. So 2 times cubic root of 2. A little bit more difficult, but I can make up problems like that for you. Alright, 19 is the Pythagorean theorem problem. So you need to know that these two sides are the legs. They are the a squared and the b squared, or the two parts that go together. And the longest side across from the right angle, that's the part that goes in the hypotenuse part, the c squared part. So make sure you don't mix up these legs. Don't put the x over here or the root 2 over here. So these go together, and those squared added up equal that 4, or the longest side added up. So x times x is x squared. The square root of 2, put parentheses around it, squared, equals 4 squared. And what happens is you get x squared plus 4, because the square root of, square root of 4 is 2, so you get plain number 2 right there. So again, root 2 times another root 2 would give you the square root of 4, which is 2. Or whenever you have the second power, and then this is a little second 2 right here, these 2's cancel away and just leave you what's left. So to solve this one here, I'm going to subtract 2 on both sides, and that gives me x squared equals 14. And then to solve for x, this opposite of squaring is square rooting. So if I have x squared equals 14, I square root on both sides, square root of this side, square root of this. This cancels away and leaves you just plain old x. And then I have x equal the square root of 14. Alright, 20 has you start to do the discriminant test. So the discriminant test is b squared minus 4ac. So just remember, a is this number 1, b is 4, c is the plain number. If you plug those in and get a positive number, that means you have two real roots. If you plug those numbers in and you get 0, you have one real number, one answer. Or if you get a negative, you have two complex or no real number answers. So just remember that. You're looking for those three things. Is it positive? Two answers, two real numbers. If it's 0, one answer, one real number. If it's negative, no answers, only complex imaginary ones, so no answers at all. So if I plug in a, b, and c, so that's going to be b squared minus 4 times 1 times c, which is negative 3. If I do that math, I'm looking to see if I get a positive number, a 0, or a negative. So here I get 16 plus 12, because negative 4 times negative 3 is plus 12, which gives me a square root of 28. That is positive, which means anytime I get a positive number under there, or a positive number for my discriminant, that means there are two real numbers on your study guide. That answer choice is A. Two real numbers. Two answers. Touches the x-axis at two places if you were to graph it. Alright, 21. So for this discriminant test, A is 1, B is 3, C is 7. So when I plug those in, I get 3 times 3 minus 4 times 1 times 7. And what happens there, I get 9 minus 28. So 9 minus 28 is going to be a negative number. As soon as I get a negative number underneath that radical for the discriminant test, that means no real answers. Only complex imaginary answers. No real answers. For that choice on your study guide, I think, I'm not sure what it is. I'll show it here in a second. But anytime you get a negative for the discriminant test, no answers. That means your graph would not touch the x-axis. So that is B. Too complex numbers, too complex, no real numbers. Not real, too complex, not real. So again, either you get a 0 under there, 1 answer, positive number 2, or a negative, no answers. Alright, now for the tough quadratic formula. So just bear with me. I think I made a couple mistakes, but I do fix them. But just watch out. I'll talk to you about them a little bit. But remember, quadratic formula, negative b plus minus the square root of b squared minus 4ac. A is 6, b is 8, c is 1. I'm going to plug all of those numbers into my formula. I'm going to look to simplify a radical number and then simplify my fraction. So x equals negative b, which is negative 8, plus minus the square root of 8 squared minus 4 times 6 times 1. And for some reason I put negative 1 in here. So what you might want to do right away is change that to 1. I will here change that down at the bottom, but this is positive 1. I'm not sure why I put negative 1 in there. So this is really 64 minus 24, not 64 plus 24 like I show you. And then at the bottom it's 2 times 6, and that gives me negative 8 plus minus the square root of 64 minus 24. So again, I will change this. It's not plus 24, that's really minus 24 right there, which I will change shortly, over 12. So I'm going to fast forward a little bit here to the correct answer, which I believe is not, here it is, it's 64 minus 24. So that gives me negative 8 plus minus the square root of 40 over 12. And then 40 is one of those numbers you need to break up. 40 is root 4 times root 10. And then root 4 becomes 2. So you replace that right here. So that gives you negative 8 plus minus 2 root 10 over 12. I'm going to break that up into its two answers. So one answer is negative 8 plus 2 root 10. So one answer is negative 8 plus 2 root 10 over 12. And the other answer is negative 8 minus 2 root 10 over 12. And remember, you need to simplify this. You're going to divide all three of these numbers by 2. Don't touch that number under the radical, but these three whole numbers all get divided by 2. They all share a 2. So I'm going to reduce them all the way down. Divide that by 2, divide the negative 8 by 2, divide the 12 by 2. Same thing here. Divide that by 2, that by 2, the bottom number by 2 to simplify it. So my simplified answer is negative 8 divided by 2 is negative 4 plus root 10, because those 2's just give you 1 right there, over 6. And the other answer is negative 4 minus root 10 over 6. And again, those are definitely more difficult for sure. So negative 4 minus root 10 over 6, negative 4 plus root 10 over 6. I'll be happy to help you with those for sure. All right, two more. All right, quadratic formula. So A is 2, B is 10, C is 7. So negative B, which is negative 10, plus minus the square root of 10 squared. minus 4 times 2 times 7 all over 2 times 2. And again, I for some reason I put a 10 in here. Don't do that. That should be 2 times 2 right there. So I will go back and change that. I'm not sure why I wrote that as a 10 right there. I think I did all the work and then found that out at the bottom. So I think I'm going to fast forward to see. I'm going to fast forward this to right about here. Just bear with me. A little bit further. Here's where I catch my mistake. So I'm going to erase those and put the numbers in the right spot, and then I'll try to explain this for you. So again, that's 2 times 2, which gives you negative 10 plus minus 100 minus 56 over 4. So that ends up being negative 10 plus minus root 44 over 4. So again, that is when I did it the right way. I put 2 times 2 on the bottom. 10 squared is 100. 4 times 2 is 8 times 7 is minus 56. That gives me 44. What I do right here is I take that root 44 and I simplify it. Root 44 is 4 times 11, which is root 4 times 11, which ends up being 2 root 11. So then when I split it up and I write that as negative 10 and I put a 4 down there where it really needs to be, then that's another problem where you simplify everything. You divide everything by 2. So my final answer is negative 10 plus 2 root 11, negative 10 minus 2 root 11 over 4. And if you divide everything down by 2, that's where I get my final answer there in black, where it is negative 10 plus minus 2 root 11 from simplifying that 44. And then I divide all of these three numbers by 2. Don't divide the number under the radical. So negative 10 divided by 2 is 5 negative. These cancel away, and then you get 2 on the bottom. So that answer is negative 5 plus root 11 over 2 equals, and then one answer is negative 5 minus root 11 over 2. And again, I'll be happy to help you go over these and give you harder ones or easier ones. And then the last one, this one, you rearrange it to factor it using the quadratic formula. So I'm going to subtract 3x first. Here I'm going to shrink this down so I have more room. So over here I subtract 3x on both sides, and that gives me 8x squared minus 3x. Remember, always write it in the order of the 8x squared first, the x number second, and the plane number third. Don't write it 1 minus 3x. So 8x squared minus 3x plus 1 equals 0. A is 8, B is negative 3, C is 1. So when I plug that into the quadratic formula, I get x equals negative negative 3. So again, when you plug in a negative number and a negative b, catch that double negative, plus minus negative 3 squared minus 4 times 8 times 1 all over 2 times 8. And if you remember, always when you plug in a negative number for b squared, put parentheses around it so remember that you're doing negative 3 times negative 3 to get positive 9. If you don't put those parentheses, you might get negative 9 out of this. Put the parentheses here so you know to make that a positive when you plug in a negative number for b into the formula negative b. So that gives me positive 3 plus minus the square root of 9 minus 48 and 32, I'm sorry, over 16. And then right here, whenever you get a negative number under the radical, stop at the math you're doing. There's nothing more you could do. That is a negative number. That means there are no real number solutions to this. It's still a graph, but it doesn't touch the x-axis. So at that point, you can't go any further. You just put no real answers, no solutions. There's no real number for x that you could plug into that problem and make it work. So you cannot have a negative underneath the square root. As soon as you see that, no solution, no real number solution. Alright, so I hope this helps you out. Be more than happy to help make up some of these quadratic formula ones for you, or the ones that you're having more problems with. Good luck, Saybrie.